Hello, everyone, and welcome back to NetApp On Air on day 3 of launch week this week. As always, I'm your host, Nick Howell. Thank you so much for joining us today. Man, we've had a packed week this week. In case you missed it, quick rundown of the week so far. On Monday, we had Chris Luth, Ben Hauser, and Mitch Blackburn going over all of the hardware announcements across the AFF, Storage Grid, and E-Series platforms, so go back and check that one out. You can also check out yesterday's episode where we went over what's new in ONTAP 9.16. And today we've got a packed show for you today because have you ever wondered how that autonomous ransomware protection stuff works? Well, we've got the data science team with us today to go over all of that and field all of your questions. So if you're joining us now, you picked a good episode to join us, especially if you're curious how that stuff works. A little bit of housekeeping first, though. If you're not already in there, come join us in our Discord community. Head over to netappdiscord.com. Come join the over 5,000 members that are in there of day-to-day practitioners, support staff. Some of our executives even hang out in there, like Drew and I are always in there for the community stuff. If you have questions, that is the place to get answers. Plus, we've got our forums over at community.netapp.com. You can find the stuff over there. All of the articles and blog posts from this week that were posted on Monday for the launch. Be sure to check all of that stuff out. That's the place where you can find all of the real technical meat. That and Discord for sure. And new this week, we are now on Spotify in video and audio format. So if YouTube's not your jam, or if you'd prefer to listen to it on the go, just pop open your Spotify app, click search for NetApp On Air, and you'll be able to find all of these episodes normally the day after that they air here on YouTube. So subscribe to the YouTube channel, follow us on Spotify, however you'd like to consume these, you can do that yourself. All right. Enough introducing stuff. It's time to geek out. Let me bring on my first guest today. He is the Director of Research and Data Science here at NetApp, Mr. Mesfin Dema. Mesfin, how you doing, man?
Hey, Nick. How are you doing? Glad to be in here.
So tell us a little bit about yourself real quick. What's your role here at NetApp? I see as Director of Research and Data Science, but what does that really entail day-to-day for people that are operating ONTAP systems?
Perfect. Thank you. We have a centralized data science team who operates across the board in different verticals. And our objective is to infuse AI and ML into different products of NetApp, including the one which will be the topic for today on ransomware detection.
Awesome. Well, let me bring your partner in crime up here, or partner in AI ML, should I say. Muneem Shahriar. So, Muneem, nice to meet you. Thanks for joining the show with us.
Hi, Nick. Nice to be here.
Tell us about yourself. Do you work with Mesfin on his team?
Yes, I'm part of the same data science team.
Fantastic. So where do we start when we talk about ARP? It's autonomous ransomware protection is what that stands for. But Mesfin, what should people know about getting started with ARP? How do you typically introduce the concept of it to people before they dive headfirst into turning it on in all their systems?
Yeah, I think the concept pretty much is an ONTAP built-in data security solutions that we have. And if I'm not mistaken, ARP has been released since 9.10, the first version of ARP. And now, of course, we are bringing AI and ML into ARP. And of course, what that means is you are using ONTAP systems to save your most critical business data. And we want to make sure that data is secure throughout the whole time. So we'll be able to protect the data and detect any kind of attack that may be happening on your system. So it is one of the critical components for ONTAP and our solution to make sure that customers are not impacted by different ransomware attacks that are happening on a daily basis.
Fantastic. And Muneem, I was talking with Keith Asen yesterday regarding ONTAP, and for some reason I thought it came out in 9.12. He told me that it came in along in 9.10, and it's been around. And I'm curious, if you guys could share some lessons learned when implementing something like this to do automatic ransomware detection and trigger snapshots and things like that. What are some things that we've learned along the way, if you don't mind sharing some of those, before we dive into a lot of the details of how we do this? I love the kind of theoretical conversation about why some of these things came along.
Yeah, so the autonomous ransomware protection has been in ONTAP since 9.13. Correct me if I'm wrong, Mesfin. And I think the team has learned a lot over this time. They have been optimizing the algorithms. It has been heuristic up to until ARP AI. And what we have done as a data science team over the past several years is that we have taken several of those heuristic learnings and have basically converted it into an ML algorithm.
Nice. So
And
that algorithm basically, as data is coming into the system and being written, we're looking for anything that might be flagged or on a blacklist or anything, any kind of file extensions. It's just constant as we're doing all of that.
Exactly. So ARP AI is essentially an inline ransomware detection application. So it actually will scan the data as the data is being written to disk. So this is going to happen in real time, near real time, and it's going to flag anything that it sees as suspicious.
Nice. Mesfin, anything you want to add on there?
Yeah, a couple of things that I want to add. Of course, the first release, as you have said it is 9.10, but there are quite a lot of learning that has happened over the years. For example, customers have to enable either at a volume level and recently at an SVM level to enable anti-ransomware. And some of the learning is essentially the existing ARP solution has a learning stage where the customer has to basically make sure that it is turned on and it is looking at the underlying data and metadata of the files before they switch it to active mode, right? Initially, I think the learning mode was about 30 days. Now that reduces to 7 to 10 days. What it means is if you have any attack within those learning period, you will not be able to have any protection against those, right? So one thing that we are bringing is, of course, ARPAI, which is trained in the cloud and deployed in ONTAP system, allows you to have protection from the day one, which is a very good thing. And of course, the learning is done outside, so it is applicable across the whole customer ecosystem, not necessarily learn on one volume and then that doesn't apply to the other volume. So those are some of the initial ideas that we want to bring in on the table.
So yesterday when we were talking with Keith about the what's new in ONTAP 9.16, there was a mention of you had to be on 9.16 to be able to take advantage of ARPAI. So sell people on that for me, if you will. What's the reason that there should be a level of urgency to upgrade to 9.16 in order to take advantage of the latest ARP with AI?
So our pitch is essentially, the first one is if you are in the old systems prior to 9.16 one, of course you have to go through learning per volume basis. You have to have learning mode, right? Your protection is relatively delayed, right? So what we are bringing in is the first one is being able to have protection from day one, as I called it out. But second one is, imagine ransomware is happening on a daily basis, right? New variants of ransomware are coming on a daily basis. How can you make sure that you have protection for these new strains of malwares from your data protection point of view? And ARPI, I don't know whether it is mentioned yesterday or not, it has built-in auto-update functionality, which means you can actually, without upgrading the ONTAP system, you are able to have more protection for latest strains, which is built into the system as well.
Yeah, and that's one of the key differences. It was just a comment in there from Khalid that said ARP versus ARPAI, and I think one of the key differences is that previously, with previous versions of ONTAP, the updates to the definitions and things that ARP would monitor would come along with ONTAP upgrades. So those would not be upgraded unless you upgraded ONTAP. Now, with 9.16 and beyond, we have the ability to sort of segment that and do updates independently of the ONTAP update. Is that a fair way to put it?
Yes, exactly.
So how did we get to the point where we're able to do that, I guess it would be my follow-up question.
Yeah, we'll provide more deep dive in the session, but our objective is, we have built the first version, which is an ML AI-based solution. And what it does is it basically leverages certain training data. These training data are collected from different attacks, different malwares, and of course, we have a large set of clean files that we have in our stock, and the model is trained on those, right? Imagine what will happen tomorrow if you have new malware encrypting the files differently, right?
Yeah.
So if you have a training data or a pipeline which basically looks out in the wild and collects these different malware, that means you are generating new training data that is exhibiting similar pattern as the malware that is being discovered. So this pipeline will basically consume this additional metadata and be able to update the model and the additional metadata needed for ARPI to run on the system. Muneem, do you want to add on this?
Yeah, I mean, ransomware is always evolving. This is like a cat and mouse kind of game, right? So we have to think not only about solving the ransomware that are already out there and how they, infect files, but we also have to think about how they might impact files in the future. So we might have to even train the model to have some kind of a future protection in case there's a new type of strain that attacks the files a little differently. Then the ML model should still be able to surface that in the detection.
Nice. So a question just came in I want to bring up here because I think this is relevant before we dive into the slides and the how all of this gets done. How do we deal with dark sites? Because it's pretty common for our systems to be in sites that aren't interconnected to or have internet access is probably the best way to say that, which in my opinion, I think is like gating off your storage to be disconnected from the internet. It's smart. What do we do with dark sites? Do we proxy it like we did in the past with other solutions, or how are we dealing with definition updates on 9.16 and beyond with regards to dark sites?
So our plan is twofold. So the first one is, of course, we'll have manual update mechanism for dark sites, right? Which will allow us to update the ONTAP and the security package in ONTAP going from 9.16.1. That is the first option that we are working. Second one is what we are doing is the auto update functionality may be coming on a more frequently than the ONTAP update. So anything that is coming in the next version of ONTAP or the auto update will be captured, let's say 9.17.1, right? If you have 3 auto update functionality that was deployed, you can actually compress all of them and release in the next version. So we'll provide, as I said, 2 paths. First one is ability to do manual updates. Second one is, of course, upgrading to the latest ONTAP system, which will capture all the improvements in ARP AI solution.
Will that only be with the major releases, so 9.16 to 9.17, or can people expect definition updates with the P patches or maintenance releases in between the major releases?
We'd expect that it can include the patch as well, but it is something that we are discussing in terms of how we can deliver this continuously.
Yeah, it's still new. We're still trying to sort of figure out like what people would really want here. I think is the way to look at it. Herman, that's a great question. Thank you. And then one more from Khalid said, do we read the actual customer data or only metadata? Any PAI data read by ONTAP while scanning?
Yeah, I can take that. So yeah, we don't really open any of the customer files to read actual data. So we're not going to open your Word file and read what's in it. So essentially what we do is we do static file analysis. We read or open the file using at the byte level and look at the byte data. At the byte data, we cannot really say what kind of text or image or whatever it is. So yeah, we don't really have that problem of PII.
Yeah, that's good question. Yeah. All right. Well, let me. I'm gonna pull the slides up, guys. Thank you for all of that sort of introductory thing to it, to ARP. But let's get this pulled up, and I kind of want to turn you loose and share with the people kind of how all of this stuff works, how we do the things that we do, how we got rated by SE Labs at 100% accurately. I'm curious because I don't think I've seen this presentation yet. I'm genuinely curious about how we pulled off this sorcery because that's what it feels like, because nobody else in the industry has figured out how to do this yet. And I'm constantly looking around for comparison's sake So Mesfin, Muneem, please just take me through this if you can, and let's pull back the layers and see how we do this.
Awesome. So we have a brief presentation. Of course, we'll go in and out of the content as needed. But really, this slide is purely from infographics point of view, where ransomware attack is happening continuously, right? 73% increase in ransomware attack over a year. That is really significant, and it is actually one of top item for C-suites to kind of address this issue, right? So as a result, you need to be able to adapt your solution, put multi-layered solution, in fact, to ensure that your most critical data is safe at all times, right? I think one thing that we want to make sure that people understand is the diagram on the right? Your critical data is at the center, and you have multiple layers of protection that are in place, starting from identity, perimeter, network, all that stuff, until data security, right? And NetApp, since we are an intelligent data infrastructure company focusing on storage and storage solutions, we have access to the data, and our layer of protection is ensuring that your data is protected at all times. And hence, all the innovation that we do goes hand in hand with your data and ensuring that you have protection. So at least on the left side, you see some pointers in there. What are customer, after at this day and age, right? The first one is customers want to minimize chance of successful attack. Of course, we have secure by design solution, which is proven over years, right? That is an important factor. And also minimize impact of a successful attack, which this session is going to provide more details in terms of how is the real-time AI-based detection and response work, and also give you a brief overview of a ransomware protection service, which is a simple control plan to comprehensive ransomware defense, right? And we have additional layers in terms of customer want to isolate critical data backups, and we have air gap solution for that. And they want to ensure data recovery, which we are providing in recovery guarantee at this point. So since we want to deep dive on it, I'll myself and Muneem will focus on real-time AI-based detection for this session. You can pause me anytime, Nick, if there's any question.
Yeah, sure, absolutely. No, keep going. I think this is good stuff. It's a good setup.
Awesome.
I love the diagram, by the way. I think that's a fantastic way to look at it, because there are 8 to 10 layers of security before it ever gets to what we can do, right?
Exactly.
With ONTAP. And I think there's physical security when it comes to network. There's software security when it comes to network. There's even more layers, sub-layers in between each of those layers, is IDS and IPS, intrusion prevention, things like, there's all kinds of stuff going on before it ever gets to us. The point is, if it gets to us, like, you've got even bigger problems to deal with if somehow you're getting a ransomware attack on your storage system, right? We're sort of the last line of defense.
Correct. And one thing that I want to add is, of course, thinking about most of the competitors, right? They work on secondary storage, essentially backup, right? Of course, you'll have backup policy, which depending on your setup can be 30 minutes, 1 hour, or every day, right? Really, the point is you may not have time to rely on the backup, right? And hence, building a solution such as ARPI that runs on the primary storage is very critical, because you want to respond immediately in seconds and minutes instead of hours and days, right? So that is the unique component which separates NetApp solution compared to most of competitor solutions as well.
Who do you see? I guess the question so I see the source here is Extra Hop. I guess I'm curious, who do you see as competitive in the market that comes even close to what we're capable of doing? Because all I see are backup vendors, and everybody is taking backups. And so relying on backups to be your answer to ransomware is not enough. Like, losing an hour's worth of data and potentially an entire footprint because it's been ransomwared or just completely encrypted, Like, that's not good enough, in my opinion. And I feel like that's the differentiator. We're not just doing backups here.
Yes.
We're doing instantly recoverable points in time within seconds, within milliseconds sometimes. So I just want to differentiate the two, because plenty of people out there, yeah, we have ransomware protection. Do you? Is it any different from the backup software you were running in 2012? Because it's kind of the same stuff. And it's not really doing anything different than the backups it took 2 years ago.
Correct. And yeah, that is the main advantage of our offerings. And of course, we are doubling down just to make sure that we have different solutions to protect your entire ecosystem as well.
Yeah.
Perfect. With that, obviously, I think the audience knows what ransomware is, but a brief description of the different steps of ransomware, where somebody is attacked by through email or other means, where they download certain malware, and that malware starts to encrypt their data, right? And as I mentioned, our focus is on data encryption, identifying malicious data encryption, and be able to alert and take action as part of ARPAI.
One thing before you move on, Mesfin, I had to pull this up because this really drives the point home even further. Yes, you can have the backup vendor. Yes, they can protect ransomware. Where are your backups being written to? Probably your storage system.
Yes.
Right? A NAS share on your storage system, or so that is so you can have those backups, but if the system gets encrypted, your backups are worthless.
Exactly.
So excellent point, Carlos. Thank you for bringing that up. I absolutely wanted to highlight that one.
Awesome. Thank you, Nick. And as I said, we are focusing on encryption, data encryption, specifically crypto ransomware attack in this case, because we are operating at the data layer, right? So there are different kind of attack. Our ARPI solution is ensuring that you don't have encryption attack. So briefly, we'll go deep dive and give audience additional information, what it means when your data is encrypted, right? Muneem have a very good slide that he'll walk us through.
Okay.
But on a higher level, what does ARPI is? ARPI is the first on-box solution, as we have iterated, that runs in real time for detection and response on NAS systems. And I just want to give huge, shout out to ARP engineering team, right, who has been working along us and be able to deploy this solution as part of ONTAP. So thanks for all the hard work that the team has put in through.
I can tell you it's been received incredibly well across the industry from the customer. Like, I have a C250 sitting back here. It's at this point relatively old. It still works fine, but like, I turned it on all of my stuff just because I can. And
yes,
I don't have any reason not to. And I've got a pretty secure network. But I don't have 10 layers of intrusion prevention and all of that stuff. I've got what you would consider a pretty standard home lab environment. Well, I don't know. It's pretty advanced, but it's pretty standard in my eyes. But why not turn it on? Yes. There was one other thing I wanted to bring up real quick from OG. This is something we can address later if it's more practical to. If we whitelist a false positive, can we please do something where we can globally allow that for all protected volumes in the cluster, please? That's here comes your feature requests.
Exactly. Thank you. And we are thinking the same thing, right? How can we ensure that customers have, less pain points, right? You can submit false positive per volume, but if it doesn't, scale out to other volume that you have, it is a burden on you to submit multiple times, right?
Yeah.
So our thought process is how can we get more customer feedback and help the customer to work less and have a better protection is what we are going after for sure. And it is, of course, definitely in our plan.
Are we doing anything on customer systems via auto supports or things like that to capture the kinds of files that people are whitelisting in order to help with our algorithm?
That is a good question. So currently, whenever ARP or ARPI is flagging a given file, customers have the option to submit it as either true positive, which is positively detected, or false positives, which comes into our backend processing. So we are working towards looking into this backend processing and how can we surface it to customer facing through the integration of our solution is what we are after. But we have the pipeline halfway already in place.
Perfect. Okay. So yes, guys, you can submit those. So when you see the pop up to submit it because it helps everybody all along the way. All right, carry on, gentlemen. Sorry for the interruption there.
No, that's good. So in here, what I'll call out is obviously your data is protected using ARPI. And of course, our automated action whenever a suspicious activity is detected is we take snapshot and we generate alerts listing. These are all the files that are impacted, right? And customer can do investigation or even take the system offline. One thing that I want to call out as well is we have also integration with CISWS, Cloud Insight Workload Security System, where ARP AI alerts can be used to identify who is a user who is actually making these attacks and be able to block at a customer, at a user level as well, right? So that is an additional layer where customer can utilize. And going back to ARPI, we scan different signals to ensure that the data is clean at all times whenever you are writing into the disks. And these are, of course, look at file content, file header, and metadata signature. Of course, we'll not be able to, show you the magic sauce and describe all the way, but we can give you a high-level overview of what does it mean when a file is encrypted, and Muneem is going to walk you through a relatively smaller session that is important as part of the RPAI solution. Muneem?
Yeah, sure. So yeah, when it comes to like crypto ransomware, there are many different ways that the ransomware application could behave. So here you see three different types of behavior. So on the very far left, we have the ransomware type 1 kind of attack, where the ransomware application is essentially like going through a directory, enumerating all the files. And let's just say that a.txt that you see here is one of the files. The first file it touched is first going to read that file at the block level, block by block, and as it is reading, it's going to start encrypting, right? And after it is encrypted, it's going to write the data to the same file, to the same blocks. And this is going to happen until it has reached from the beginning of the file to the end of the file. And once it has finished encrypting all the blocks in the file, it may also change the extension of the file. So from a.txt, it might like append.wannacry, to the end. Now, different kinds of ransomware may have different kind of extensions added to the file name, and that actually gives us an indication of what kind of ransomware it is, right? So, but there are also ransomwares which do not change the extension, but generally most do. And type 1 ransomware is something that we see the most often, right? And then we also have type 2 ransomware, which is in the middle. Now here, instead of reading and writing to the same file, the encrypted data is actually written to a different file, right? And of course, the different file may still have a ransomware extension. Now, you might say, okay, what's the point of having the original file? Well, the ransomware is actually going to delete the original file after it has written the encrypted file. So that's what it does, is after it reads the original file, only the encrypted file stays and the original file is deleted. And finally, in type 3 ransomware, which is, I think, the least kind of common, what the ransomware does is it's going to read a number of different files and put them in a password-protected zip file, for example, and then it's going to delete the source files. So these are the three different kinds of ransomware behavior that's out there in the wild.
So those present, Muneem, they present three different sort of recovery scenarios as well to recover from in the event that you did not have ARP. I'm thinking about like three different things. So if it is actively deleting files, sure, you could pull them from backups, but when was the last time you ran a backup? If it's all in a zip file and then it deletes all the source files, well, can't you just restore the deleted files? Isn't there going to be some kind of audit log or something? I'm asking this intentionally to sort of provoke the listeners to think about sort of the recovery scenarios they're going to go through in each of these situations as well, because that's really what this is trying to illustrate here, in my opinion. Like, sure, these scenarios are great, but how do you recover from each of these? And you need to have a playbook for recovery from each of these as well, because it's not if, it's when, guys. It's not if, but it's when this is going to happen to you if it hasn't already.
Yes, right. And yeah, that's the reason you need backups. You need backups as frequently as possible, right? So that you don't lose much data. I mean, the more often you have the backups, the sooner you can go back to the most recent backup to restore your data.
Yeah, it's really clever.
One thing before we go to this section that I want to mention is Muneem has shown 3 different ransomware attacks, right? I just want to make sure that the audience clearly understand that our solution is not signature based, right? Looking at ransomware type 1, for example, people will say, okay, I'm going to look for this extension and I'm going to block or trigger alert. No, it doesn't work that way. There are multiple components of attack on a given file, and our solution basically extracts features and embed all of them to make a prediction based on ML and AI system.
Excellent.
Muneem,
Right.
go for it.
Yeah, sure. So we talked about the different kinds of signals that the ML algorithm is going to look out for. So the first signal that we want to look at is how are the bytes changing within the file when encryption is happening. So if you think about computers, the way it stores data is in terms of bits, right? And bit is essentially 0 or 1. We call that binary. Now 8 bits together, it makes up a byte, and a byte essentially varies from 0 to 255. Right? Or in hex, we say 0.x00 to xff. Now, 4096 bytes will make one block, and one block is the size of the data in storage. And a file basically contains of many blocks, right? So on the top right screen, you can see that a file has many blocks. And essentially what we can do is we can read one block at a time, look at all the bytes in that block, and create some kind of a distribution, right? If we call this the byte frequency distribution, and what it essentially does is it shows the relative frequency of each of the byte values in that one block, right? So here on the right-hand side, you can see that the distribution is kind of sparse, right? It has a lot of peaks on certain values around 100, and then some of the other byte values don't have any kind of occurrence. So if you go from one block to the next, this distribution is going to change. So here, what we are trying to show you is something a little bit beyond that. So here we're talking about encryption. Here we're talking about entropy, sorry. So entropy is essentially a measure of randomness. So what we are interested in here is file entropy, and we are calculating that via Shannon's entropy formula, which is given by the blue box over there. So the PI value in this formula is essentially the value of each of the bars in that distribution. So we sum up all these, we basically compute this sum, and we call that the Shannon's entropy. And this entropy value essentially varies from 0 to 8. So think about it this way. A file that is which has the distribution very sparse is going to have a less uniform signal. And a less uniform signal essentially means that it has low entropy. So text files or any kind of ASCII files are going to have low entropy. On the other hand, if the distribution is very uniform looking, the one you see at the bottom, these kind of distributions will have high entropy. And as a result, the Shannon's entropy value that we calculate is essentially close to 8. And 8 is the maximum the entropy can be, right? So this entropy value itself is an indicator of whether encryption has happened. So if the block was originally having an entropy of 3.9 and now it has an entropy which is much higher, that's indicative that maybe the block was encrypted. And of course, when you come to zip files, which are archives, zip files tend to have values which are also kind of high.
Where is all of this happening, Muneem? So for those of us familiar with our systems and ONTAP, and is this happening in NVRAM as the block is being processed through Waffle before it's being written down to disk? Like, where is all of this taking place?
Yes, I think it is happening in the NVRAM.
Okay.
So for each of these buffers, we essentially calculate the entropy and have it ready over there.
Wonderful. Okay. Yeah, that was my expectation, that we would do this before it ever got sort of sent down to disk. It's almost like a buffer area to to do some fancy calculus and be like, hey, I don't know about this one, and kind of quarantine it in a way?
Right. I mean, we keep a log of the entropy on all the blocks, right? So that's essential as the blocks are coming in. Yeah.
Okay. That's good stuff.
So one thing you will note here is that even normal files such as zip files that you see on the right-hand side, if you look at the blocks and calculate the byte frequency distribution, the distribution of a zip file is going to look very similar to that of an encrypted file, right? So the entropy of compressed data is, again, very close, like 7.8 in this case, and that's very close to, say, 7.95 for the encrypted file. So one of the most frequent mistakes that ransomware applications might do is when it comes to these zip or compressed data, because they tend to look very similar to that of a encrypted. But we have taken care of that problem because we just don't look at entropy like Mesfin showed. We look at other kind of signals from the file extensions, another kinds of metadata, and this enables us to weed out many of these false positives that might be occurring in those naive systems due to just using entropy alone.
What are some of those, if you don't mind me asking? Like, I know there's one where if we have a file that it's cold data and it hasn't been touched in 6 months, 2 years, whatever, and all of a sudden it's getting a ton of writes. Like,
yeah, exactly.
Is that a trigger to just volume snapshot right away, or?
I can't go into the exact details of what other exact signals we use, but I can say that yes, that is suspicious if something that has not been used for a long, or file that has not been accessed for a long time is now being accessed. And also, it's not just one file, but many files being accessed one after another, right, in the same directory. That is, of course, suspicious.
Yeah, absolutely. Hey, a couple of questions coming in for you real quick. Let me pull this down. Khalid asked another one. Says, do we scan background or inline? I think both.
We scan inline.
Okay.
The entropy is calculated inline. And of course, there might be other steps like file extension and so on, which might be falling after that, after the file has, say, been closed. So yeah, we do basically inline. Actually, we do both.
Yeah, okay. The next one from OG says, what if you encrypt only some of the data? So like every 50 bytes you encrypt, the file will still be unreadable. How do we deal with that situation the same way as if the whole file got encrypted?
Yeah, I mean, if you encrypt every 50 bytes, that is going to dilute your signal, the distribution a bit, but the distribution is still going to look different. And the way our ARP AI algorithm works is it's actually going to even detect that it's sort of like a partial encryption case, right? Because the ransomwares are not just going to encrypt part of the data, but they're also going to change the file extension, and it's going to change the file header, for example. If the header is not readable, then we will still be able to detect it, even if we have a case like this.
As far as, so a lot of good questions are triggered from the stuff we're going over. So this is fantastic. What is the performance drift with or without ARP AI? Are we seeing any performance heavy overhead with ARP scanning?
Actually, the ARP has been optimized since the original ARP, right? ARP AI is actually more optimized when it comes to calculating entropy, and it actually has a lower performance overhead.
Yeah, and one thing that I want to call out is, we have 9.15.1 tech preview release, right? But after that, the engineering team has worked hard to kind of optimize the different operation, computation of entropy, all of that, and embed the optimized solution as part of 9.16 release. So we are happy in terms of the performance impact that there's no significant change between the two versions, but with the added capability of protection on multiple kind of files, as well as no learning mode as it is.
Yeah, but is it fair to say that they won't see those improvements until they upgrade to 9.16?
Correct.
Okay. That's not something that's universally that you figured out with 9.16 that we can retroactively apply to older versions? Got it.
Yes.
All right. And so Thomas asked, so if I'm a bad guy, I encrypt data and rename it as .zip? It's kind of a funny, sarcastic question.
Yeah.
Yeah, it's one way to try and do it. If you guys are interested, so it brings up an interesting point, and then we can get back into the slides. If people want to test this kind of stuff with their system, do you guys have any recommended resources if they want to sandbox their own environments to be able to encrypt some test data and test the mechanisms that work in 916? We have a lot of customers that have sandbox environments where they test new versions of ONTAP anyway. So what would be some guidance that you could give them on how to test some of the ARP functionality?
Yeah. Couple of things. First of all, let me address a question that he sent, right?
Yeah.
That is exactly one of the first tests that we did, right? Essentially, how can you differentiate the existing solution to the new solution? What if, people are encrypting data, but using the existing extension like PDF, docx, right? So we have tested it very well on those data, and we are confident enough to say that our detection capability is really good at this point. Second one, there is a manual in terms of how you can set up at least 9.15.1 tech preview, which ARPI was initially released, as well as how you can test it. And we can potentially provide that link after the recording as well in the channel.
Yeah, fantastic. Alrighty. Muneem, carry on. Sorry for the interruption. Wanted to get to some of those questions before we got too much further.
So yeah, here we see like a chart where we are basically showing what the distribution of those entropy values look like for various different kind of file extensions. So for example, on the bottom, we have ENC, which means just it's a general extension for all kinds of, let's say, ransomware application. And then following that is zip. And some of the other ones to the far right, you can see that DXT. And if you look at those annotations there, like the min, 25 percentile, 50th percentile, and 75 percentile, and max, those are the different entropy ranges, right, that we calculate for just text files. And this is, again, based on a large number of text files from open source data sets. So we can see that for a text file, the entropy generally varies from 2 to around 6, right, with the median of around 4, right? So if this text file was encrypted, then the encryption value would be very close to 8. Now,
Wow.
8, it doesn't fall in that range, right, between 2 to 6. So that is suspicious for a text file, right? So the one thing I want to call out here is that if you look at, again, the zip files tend to have entropies which are very close to 8. And again, this is where we have to be a little bit careful, because zip files, because they have values very close to 8, they can trigger false positive in naive systems. And in ARP AI, we are looking at the entire signal landscape to essentially not classify them as encrypted. So if you were just relying on entropy alone, this is not going to work. But if we use a whole bunch of other signals to make sure that zip files are not detected as encrypted.
Yeah, and it's a good lesson. There's never just one silver bullet that just points directly at the thing. This is a combination of calculations and measurements across the board that are determining if then else kind of calculations of sorts to figure out whether this thing is malware or not. And all of this takes how long to do? Have we actually measured the time that it takes to do this? Are we in the milliseconds or the nanoseconds yet?
Probably in the microseconds.
Microseconds. Wow. Okay. This is all happening in microseconds. That's crazy to me. Okay. So the one big takeaway I have from this is like there's a big range for the doc extension. Is there a particular reason for that? That stands out to me on this graph as opposed to all of the other examples there.
Yeah, because documents can include images, right? And images can have high entropy. Same with PDFs, and PDFs can be compressed as well. Yeah. Some applications will compress them. As a result, you can see that PDF documents have high entropies, which are close to 8.
I didn't even think about the image embedding part of it. That's fantastic.
Well, one thing that I want to add, Nick, is essentially you may hear, from different vendors or solutions that they'll say, they look at entropy and they basically detect attack, right? So this few slides is to demonstrate that, entropy by itself is not good enough, right? And the reason why we are, adopting additional signal is to improve our performance, which is demonstrated, of course, in the independent testing in AC Lab. But not only that, the additional component is we are using ML which means we are actually extracting signals and features out of this data. And hence, imagine what that captures is it generally captures what does encryption look like from signal point of view, right? It doesn't matter whether it is Lockbit or WannaCry or any other malware, as long as you are able to extract those signals and capture it through the ML algorithm, you are able to detect these kind of attacks, right? So we just want to make sure that people realize the value of using AIML versus heuristic approach, as well as to show that entropy is not enough by itself.
Right. That's a good point. And it's good to continue to drive that home because I think a lot of people depend on that, and they depend on just file extensions and some of the basics for detection for when they're in their definitions and things like that. But it's so many other things all combined with entropy and file extensions, and just to really determine that kind of stuff. This is fantastic. I feel like we need to share this kind of information a lot more. It's great that we can go out there and say, now we can use AI to stop ransomware on your storage systems. This kind of stuff is the power that we need to showcase a lot more, and I love that you guys are here doing it. Thank you.
Awesome.
Quick question came in from OG. Give me 1 second. Man, you guys are getting all the good questions today. This is what I hope for. So, can we exclude a certain file type beforehand if we know it always includes encrypted compressed data? It's a good question.
Yes, we can. And of course, we have to embed in our solution. But this is a guardrail or business logic that can be put in, right? Imagine, specific customers want to encrypt their file as well. Very, new extension, custom extension that are using, a lot of signals that are not there, right? So being able to build a business logic around it and ensure that they are not getting the alert fatigue is one important component that we are considering and building towards.
Yeah, good point. Great question, OG. And Khalid asked, can we enable this on existing data? If so, how it scans data tiered to a capacity tier? I'm assuming that's versus local tiers versus capacity tiers. So, yes, you basically go to the volumes, regardless of what tier it is on, and you check a box that says autonomous ransomware protection. Or you can do it in CLI as well. But it's that simple, Khalid.
One thing that I want to add on this, Nick, somebody asked me at Insight, right? They said basically I have 10 petabytes of data sitting on my, drives. What will happen if I upgrade from 9.13 to 9.16 or 9.15 tech preview, right? One thing that I want to make sure is the solution is based on write, right? Inline write operation. So if you have 10 petabytes of data, that is called nobody touched it. Of course, we are not rerunning it, right? The moment that certain content in there is modified, of course, that means it will trigger modified blocks, and the write operation at that time will be able to operate on it. So in terms of performance impact, always know that it is on blocks that are being modified in the system, not necessarily because they have a large data sitting in there. It doesn't mean that we run and kill your system as well.
Yeah, we're not scanning every block of every volume of across your entire cluster. Like that's not how this works. It's based on writes, whether those are overwrites or new blocks coming in. Yeah. Good question, Khalid. All right, back to the slides real quick and take it away.
Okay, perfect. This slide is to kind of demonstrate how do you catch up with the latest ransomware attack, right? Obviously, we can build a ARPI solution which is built one time and use it for years, but things are changing over time on a daily basis, right? You need to be able to look at the new malware types that are coming in, enrich your data sets, and then build a new model on top of that and be able to deploy it, right? So this is kind of showcasing the whole view of what that looks like. Specifically in the data generation view, I have few more slides to demonstrate what it means. But one thing that I want to call out is we have this pipeline running on a daily basis, collecting data using third-party vendor source, and then building new models, assessing the performance of the model, and eventually packaging it and deploying it into our ONTAP systems. So real quick, what does that mean, right? imagine we start with open source data set, forensic research data sets. Of course, we don't want to use customer data set for this purpose. And our system resides in the cloud, and we have a bunch of clean files, right? So what we'll do is we'll have a sandbox environment where we copy these clean files. And then after we copy these clean files on a daily basis, we'll source what is the new malware that's happening in the wild, right? Take a sample of the malware, encrypt these clean files. So you start with 100 files that were clean. Now it is encrypted. You have 100 or 100 plus README files essentially in your sandbox, right? So imagine doing data at scale. Every malware type, you build this training data and collect the training data on a daily basis, and which means now you have a massive training data set, right? This is continuously updated, as I said, from what is being seen currently in the wild from malware perspective. And once you have that, obviously the training data will be used to build new ARPI models, and these models will be compared against what is deployed currently in the system. We have, of course, model registry, which will check, okay, this was the model, and take a sample of out of distribution data set and assess whether to check whether the new model is better than the old model. And if it is better, of course, you want to deploy that through the auto update mechanism, where customers are alerted saying that, hey, in system manager, hey, there is a new update coming in, why don't you deploy it? Of course, one thing to note is our package is encrypted, right? We talked about, manual update earlier. It doesn't mean that because you have access to the website to download the package, you cannot open it and do anything about it, right? So we have encryption taking place, security, all of that is incorporated when we are deploying these models back to the ONTAP system on a regular basis.
So if you have a system that's been compromised and needs to recover, are you still able to go in and apply new definitions as part of the recovery effort? Is that a sort of best practice there of how we do help with recovery?
That is a good question. Since I mentioned that our operation is on write, imagine you have a write operation until yesterday. Ransomware attack happens to be, you happen to be a patient zero and your system is impacted, right? But because we are updating the model today, we will be able to protect any customer who may face this ransomware attack tomorrow, right? On the one which is impacted and the data is already sitting on the disk, our solution, if there's any gap, right? Of course, we have shown that our recall is 99% and false positive, at least in the independent testing, is there's no false positive. So because of this accuracy, we'll expect that you'll have snapshots taken even from the previous attack, but going forward, the update will ensure that certain attacks are not happening and impacting your data.
Got it. Okay. Good to know. That was involved with a couple of things here in Vegas last year, and the attacks were ongoing.
Yes.
And it was not a storage system that was being impacted, but they were very out of date, and they were, the attack went on for several months before they finally nailed down and got rid of all of it. So it's interesting. This isn't like an antivirus scan. These are typically ongoing attacks. They have typically breached through networks, have created accounts, admin level accounts, and are sitting waiting in the wings until somebody says go, and then it just goes. From multiple vectors, it's coming at it. So even if you have a volume that's been attacked that is now protected and snapshotted, it doesn't preclude any other attacks from happening across the board to any of your other volumes throughout your clusters. So that's why I always ask, like, in an ongoing attack in real time, should one of the best practices be to get the latest packages if they haven't already? Because I feel like that could help stem the tide a little bit in the middle of an attack.
Yes.
Good. Yeah. Good call out there, OG. This sounds like a great episode for NetApp on NetApp. Yeah, I'll talk to Matt Brown about that. We'll be really interested in what kind of infrastructure and NetApp features you're using on the back end to enable this continuous AI learning cycle. Yeah, I'll talk to Matt about that, see if he wants to come on. And we need to do a NetApp on NetApp episode anyway, and talk to Mr. Matt Brown and company about how they're doing things internally here at NetApp. Well, I'll commit to getting him on, OG.
Awesome. I think we have only a few minutes to go. The last point that we want to make sure is, of course, different vendors and solutions will say, we have ransomware protection and our efficacy is very high based on internal testing, right? So because of that, how can we validate it, right? So to address that issue, we are openly engaged with a company security firm called SC Labs, which does multiple testing across, different companies. I remember, Microsoft using it for email security testing and other companies as well. So our engagement was essentially, okay, we built the RPI model integrated in ONTAP. Actually, you guys will be early access program, a part of the AAP plan. And then, of course, NDA, all of that in place. We are going to give you lab on demand instance, running RPI, and then do whatever you want on those systems, right? So in that test, what they did is they collected latest malware variants. I think the report will be shared as well, and apply close to 4,000, encrypted files into our system and assess the performance across these different malware types and give us actually a triple A rating after the test, right? Which shows that we are going above and beyond to make sure that our solution is independently tested and validated before we ship it to our customers. And the test, of course, you can see recall 99% out of the 4,000 samples, only 1% being missed, which our target is actually 99% for both precision and recall. And the precision actually didn't see any false positives in those testing. So this further validates that we are confident enough to independently test our solution, which unlike other competitors where that number is yet to be found, right? So that is one thing that I want to call out.
Yeah. This was a huge hit. We talked about this yesterday with Keith. This was one of the highlights of even just the ONTAP release, and it got the main stage at Insight during the keynote. This is a huge deal, guys. The fact that we got 100% precision from SE Labs, like, that is not to be slept on. That is a massive, massive deal. So, I mean, congratulations to you and the team, Mesfin. This is a huge achievement that I don't know that we've seen this in the industry yet. I think we're one of the first ones to achieve this kind of benchmark.
Yes.
Quick question here. I do want to talk about Blue XP, but one quick thing before we get into that. Any good news for SAN workloads integrating with ARP AI?
We cannot talk about it right now on that.
Watch that space, Khalid.
Yeah.
Yeah, we'll leave it there. We did have some questions come in about Blue XP and licensing and stuff like that. I want to make sure we cover that before we get out of here. So let's go over the difference between what happens with on-prem systems with their ONTAP 1 license and how they can leverage it in Blue XP for some of their cloud services.
Unfortunately, I don't have enough information about the licensing, so I cannot answer that question.
I do.
But but our point is currently you have different solutions, right? And ransomware protection service, RPS, what it does is it is a single control plane to do everything, right? From starting using actually the 6 NIST framework that I skipped in the previous slide, right? From discovery into protection and recovery, right? And as part of that, ARPI is one of the pieces that will be used in the detection phase. And the orchestration will allow you to do end-to-end protection recovery with little effort in one page, pretty much on in our Blue XP portal.
I love that. So the big takeaway for me here is, guys, if you have storage systems, ARP is included with your ONTAP One license for your systems on-prem. If you want to extend that into BlueXP, into our control plane, and integrate it across in a hybrid way, maybe some of your cloud systems, and that there is a nominal fee that goes along with that. Of course, talk to your account reps, talk to your partner resellers about how that works. But yes, we are looking at how we can leverage this in a more universal way through BlueXP than just another license you turn on your storage system. That's a very one-off manual process as opposed to looking at it in a more universal context. Because I don't think ransomware attacks are single system, single node kind of attacks. They're going to be multi-vectored across multiple domains, all of that. So it's something to consider. It's something to keep in mind. If you're using cloud resources and you're a consumer of BlueXP, you're going to know who you are and you're going to value that kind of add-on. If you're just a tried and true on-prem infrastructure engineer and company, and you have everything in your colo facility or your data center, you're going to know who you are, and you're going to say, I don't really need that BlueXP stuff. I'm good with my ONTAP One license. It's very easy to figure out which lane you swim in, but we always encourage people to look at BlueXP as an alternative to things like System Manager, where you can manage things in a more estate-wide thing. You can look at all of your systems, right? So keep that kind of stuff in mind when you're thinking about the licensing and whatnot. Let me see. There was one question that came in here real quick. In the case of a new ransomware that requires an ARP update, how do you plan to notify that those updates are available? Is there a mailing list? Is there a notification system? How do people know when you guys put out a new package beyond 9.16?
Yes, the system manager notification system will be used. I think you can set up email, all the other settings in there. Previously, I think time zone update and a couple of other updates have been done in that system. We are actually leveraging existing systems, so you should be able to see alerts telling you, hey, there is a new security package coming in. You can apply it, or opt-in automatic update as needed, but that is available, and we can add additional information on that too.
It'd be great if, so I remember Hernan at the beginning of the show was one of the ones that asked about dark sites and things like that. I'm trying to, so when System Manager might not be a viable option. Is there anything outside of System Manager through the support site or anything like that they can sort of subscribe to get updates? Is there an RSS feed of some kind that we can send out to people outside of System Manager to know that they can have updates? Because if they're not connected to the internet, System Manager is not going to know that there's a new package.
That's a very good point. So our update mechanism, of course, we have System Manager and manual update. But one thing that I'm not sure about is whether there is an email notification or such feed whenever a new package is uploaded in that system. So we may need to follow up in terms of how can we notify people in that area.
Yeah, I think that would be really good for us to look into. Thank you so much, Hernan, for that good point. Let me get your slide back up here. We're running a little bit long, guys, but I want to make sure I don't want to miss the BlueXP stuff and some final thoughts here. So make sure you guys get through this stuff real quick.
Okay, I think we have covered it on a high level. As we have said, Ransomware Protection Service is using the 6 NIST functions, where we are actually automatically discovering different workloads and applications. This is important because our discovery allows us to do application consistent recovery as well, right? So that is already baked in. You have a one-click protection to do backup, immutable, secure configuration, all of that, as well as malicious file blocking, which comes from F-policy point of view. And we spend an hour on detection, so no need to talk in there. And we have actually, I think, have done already 1 or 2 integrations with SIEMs, Splunk, and another one, which I cannot recall at this point. So your alert is surfaced further as well through SIEM.
I can't remember the name of it either. It's escaping me right now. I'll think of it.
Awesome,
we talked about it on Monday morning.
Okay. And of course, the last 2 are, being able to orchestrate recovery. Your alert are one area, you can recover 2 different snapshots. All of that is baked into the RPA system. And of course, policies and governance are in place as well. So that is, I think, the last slide that we have for you today.
Awesome. Awesome. Well, guys, this has been absolutely fantastic. Some really lively chat going on today. We'll see, Thomas threw it in. Thanks for the great stream, great content, and amazing technology. I think we're really, the funny part about this is I really think we're just scratching the surface of what's possible with this kind of detection and remediation. We had Artie Noel on last Wednesday, talking about what he's doing in Snap Center, or what the Snap Center team is working on, and how they're integrating with BlueXP even deeper beyond VMware, right? So I look at, okay, well, now you take ARP and you tie it together with the application recovery that you were just talking about, Mesfin, and now you have this seemingly automated process of recovery that's leveraging the snapshots that were triggered by ARP.
Yeah.
You guys see where all of this is starting to come together? How we're going to automate this problem away? And I think we're really just scratching the surface of all of this. Mesfin, Muneem, any final thoughts for the viewers before we get you guys out of here?
Thank you for attending the session. Update to 9.16.1 as soon as it is available.
You don't have to sit around and wait for P2, P4, and just YOLO it. Send it.
Yeah. Muneem?
Yeah, thank you for bringing me on the show.
Yes, OG called it out for me. Thank you guys for being here. It was Microsoft Sentinel. That was the one. I couldn't think of it. That was the other Simsing integration we did. An AWS Security Hub too, apparently. That one I didn't know about. But yeah, we talked about those on Monday. I think Chris Cornwall brought those up as part of the overwhelming launch that we did this week. It's been a long week, guys. Mesfin, Muneem, thank you so much for the time today. I'm sorry it took me so. We've been trying to get you guys on since like August. Like it's just been a conflicting schedules and insight and all that kind of stuff. But I'm glad we did it this week, coincidentally aligned with the launch, because we could talk about all of the 9.16 stuff now as part of it. So anytime there's any major updates, please come find me. Let me know. We'll have you guys back on the show to update the audience here.
Awesome. Thank you, Nick, for having us.
Yeah, thank you.
You're welcome. All right, guys, thank you so much for joining the show today. I really appreciate it. This has been a busy week. We're not done. I got a surprise for you tomorrow, but you're going to have to subscribe to the YouTube channel here to find out, because I gotta go make a thumbnail in a hurry and put it up for tomorrow. But make sure you subscribe to the YouTube channel. Make sure you come find us at netappdiscord.com. Come join our community of over 5,000 practitioners, support staff, me and Drew. We all hang out in there. And thank you guys for being a part of that community. It's really beneficial for a lot of our new people that came up to me at Insight and go, Nick, I'm a new admin. How do I learn anything about NetApp and ONTAP? I'm like, come join our Discord. Here's OnAir. Come watch. We're going to do some 101 stuff. So stay tuned. Make sure you subscribe. Make sure you're in Discord. Those are the two big places to be. And go see the community. Go read all the technical blog posts. That's where the real technical content goes, is actually in community.netapp.com. It's not on the main website. So just a little hack, hint, wink, wink. And we'll do our best to continue to bring all of the technical content to you guys here as well, as deep as we could possibly go on NetApp On Air. But my name's Nick Howell. Thank you so much for joining us today. Shout out to Drew Claybrook, our community manager, my behind-the-scenes producer. Thank you, sir, for all you do. And we'll catch you guys next time. Take care.